Take one.
Alright, this is problem number 160 from the SOA Sample C exams taken from the 09. Let's read the problem. Given random observations, 0.1, 0.2, 0.5, 0.7, 1.3, you test the hypothesis that the PDF is f of x is equal to 4 over 1 plus x raised to 5, x greater than 0. Calculate the KS test statistic. You can find that the integral is from 0 to x, and that is the CDF, and this is what we get, 1 minus 1 over 1 plus x to the 4th. We then go on to make this table. Our first column is really simple, it's just the observation values. The second one, f star x, which is the notation we talked about in class, it's the CDF evaluated at these respective values. This column is the empirical formula as the empirical Fn. What we get is 0, 0.2, 0.2, 0.4, which we get as 1 over n, that's the number of observations. We take it from the right and the left values, hence we have 2 values for each row. The max difference is just 0.317 minus 0, that's 0.317, and 0.317 minus 0.2, that is 0.117. We now take the maximum of these 2 values, which for this row is 0.317. The max difference is the KS test statistic, what we are looking for. What we now want to do is just find the max of these 5 values, which is 0.402, and that's our answer.
Alright, this is from SOA Sample C exam number 172 from fall 2009. We are given a random sample of 5 observations from a population, and they are 0.2, 0.7, 0.9, 1.1, and 1.3. So we're using the KS test for testing the null hypothesis H naught, and we're testing that the PDF is small f of x is equal to 4 over 1 plus x to the 5th power, and x is greater than 0. So our critical values for this problem, given the levels of significance 10%, 5%, 2.5%, and 1% are respectively 1.22 over the square root of n, 1.36 over the square root of n, 1.48 over the square root of n, and 1.63 over the square root of n. So moving on to the solution, we're going to take the integral of big F of x, and it is the integral from 0 to x of 4 over 1 plus t to the 5th power, and that's equal to 1 minus 1 over 1 plus x to the 4th. So this table is made up of 4 columns, the first being our observations, 0.2, 0.7, 0.9, 1.1, and 1.3. The second being the f of x valued at our observations, and it's 0.518, 0.880, 0.923, 0.949, and 0.964. The third column is our Fn, which is our empirical distribution, and that's just 1 over our number of values, which is 5. And we're taking the limit from the left and the right, so that's why we have these 2 values, 0 and 0.2, and you just do that down the rest of the column. And then the next one is the max difference of these, so we're going to do 0.518 minus 0 and 0.518 minus 0.2 and take the max of that, which is 0.518. So you do that for the rest of the observations, and the maximum value is 0.68, and that's our D, our test statistic. So as a conclusion, our critical values are 0.546, 0.608, 0.662, and 0.729 for the given levels of significance. And the test statistic is 0.680, and that's between 0.662 for 2.5% level of significance and 0.729, which is a 1% level of significance. And therefore the test is rejected at 0.025 and not at 0.01.